Hey everyone.
My bad.
No, you're good. We have multiple computers, but thank you for coming to the Othello. I know you can't see the name, but the Othello help session. We're just going to be going over the logistics of the project. And then at the end, if you have any questions, feel free to ask them. I'm Sarah, by the way. Um, Jinho's right here,
Okay.
Jackson, and Lana. Okay. See if I can. Okay. Just a reminder that you should be filling out the final project declaration form by today at 11:59. This form is binding, and after the deadline, if you want to switch, you have to email the HTAs, and permission will only be granted for extenuating circumstances. Yeah. Okay. An overview of what we're going to be doing today. We're going to go over how to play Othello, writing the GUI, switching turns in the referee class, checking for valid moves and flipping pieces, working on the copy constructor and project design. Obviously, some of these words might not be clear now, but they'll start to become clear as we go throughout the presentation. And there are also help slides for the mini-max that is linked there, and you'll also learn about kind of what that is later. Okay.
All right.
Yeah.
So first we'll talk about writing the GUI for this project. So our GUI, graphical user interface, pretty much just like what shows up when you run the game, has two main components. So we have our board, which is an 8x8 grid that contains pieces and has a border, very similar to Tetris in that way. And then we also have a control dashboard that configures the game settings. So these are kind of like the two main things that you'll see on the screen. So some questions to think about as you're thinking about making this GUI. How can you represent and store the board and the pieces? Think back to past projects like 2D arrays, that kind of thing. And then what components should know how to react to user clicks? So like when I click on the board, a piece should show up. So how can I design my GUI so that the board responds to that user click and makes some sort of a graphical change? So the board itself, we kind of have like a little GIF of it there. There's a few different implementation options. As I mentioned before, both of them use 2D arrays. I mean, you can kind of tell just based off of looking at it. It looks pretty similar to the kind of grid we used in Tetris, but there are some key differences. So one implementation option is to use two different 2D arrays that kind of like overlay each other, where one is for the squares in the background and the other is for the pieces on top of the squares. And then another option, and this is our recommended approach, is that you just have one 2D array. So it simplifies it. You don't have to worry about having two whole separate 2D arrays that you have to change every time you want to add a piece to the board or flip a piece or whatever. But just have one 2D array of smart squares. And these squares will both be the squares that you see in the back of the board and have the ability to contain a piece in the middle of them. So I think this makes your game logic a little bit easier because you only have one data structure that you have to worry about looping through and changing. So this is why we recommend it, but there's plenty of different options that if you feel a lot more comfortable with the other one, feel free to choose it. So when will the board need to graphically and logically change? I kind of alluded to this earlier, but when a player adds a piece, you need a circle, either black or white, to show up on the square that that player is trying to add a piece to. So there you need to both graphically and logically add a piece to the board. Um, when a sandwich is created and pieces change color, so you'll learn a lot more about what a sandwich is when you're reading through the Othello handout, but it's pretty much by the rules of Othello, you flip a piece. If I'm black and I put a black piece down, and it pretty much like creates a sandwich where there's white pieces in between two black pieces, then I flip those white pieces to become black, and that's kind of like the main rules of the game. So when that situation happens, we need to flip pieces, and that is another time when we'll need to change it graphically and logically so that the pieces actually like change color, but then also logically we know that they're changing color as well, so that future sandwiches don't get affected by that. And then the last thing is that when a human player is about to make their move, um, the board will highlight all the possible moves that that human player can make. So the squares will be highlighted a slightly different color to show the player where they can make their move. And then when will the board not need to graphically change? And you'll learn a lot more of this as you're reading through the AI part of the project. But as the AI is making potential moves in its recursive minimax algorithm to figure out what the best possible move is, all these potential moves it makes are not actually graphically made. They're just logically made on a separate board, a copy board that only exists logically. You don't actually see it appear graphically because you don't want to see all the potential moves. You just want to see the moves that ends up making. And we'll talk about this more later. The other main component of the GUI is this controls panel that I talked about before. It's given to you in the stencil. You just pretty much need to figure out how to use it in your use it with your game. So this is associated with your top level logic class, your game class to configure your game settings. And what you have to implement basically is how to reset the game using the reset button, set the game's player settings. So whether the white player will be human, computer one, computer two, computer three, same for the black player. And then also adding the score and game over labels to the pane, since these are defined in the controller class. And we've provided you with a bunch of to-do comments in this class to figure out how to do this because because it's code we kind of give you, it's not super clear like how you would do this on your own. So we do give you some to-do comments that I think are pretty good at telling you how to implement all of this. But feel free to ask any questions, obviously, on Ed or anything, if you're not super sure about what to do. And also don't worry about 100% following the code that we've provided if you feel like you'd rather do it a separate way.
Okay. Now I'm going to be talking about switching turns in the referee. So, as you know, the game would be pretty boring if we only had one player. So, something we need to do is figure out how, when a player's turn is over, to switch to the next player. And we can do this by having a referee class. If you think back to tic-tac-toe, there was a CS15 controller, and this time you're kind of going to be applying that logic to this project. And what the referee would be doing is it would keep references to both players, so the black and white player, and keep track of which one is the current player, because when one player is moving, the other player is not. And then it tells the player to move when it's their turn. And going more into this, the referee can handle checking for illegal moves. I think we talk about like putting down pieces in a bit, but illegal moves are just essentially you can't put a piece ran on any square on the board. It has to create a sandwich. So the referee will know about that, or the referee will keep track of that. The referee also keeps players from moving out of turn, which is, I think, like not when white goes or black goes. It keeps the players from moving when the game has ended. And it makes sure that makes sure that the human doesn't try to move during the computer player's turn and vice versa. The referee should also contain a timeline. Why, you may ask? The computer player moves should be updated on screen with each timer tick. And how do we do that? The first thing you do after the timeline is called the keyframe method, it should call stop on the timeline. But then where would we be calling play? And these are all great questions you should be asking yourself as you're coding or as you're thinking about the design of your program and the logic of when players should be moving. But something to think about is, should the referee tell itself that the player's turn has finished moving, or should the referee be told that a move, either a human player and a computer player, has ended? And something just to know is that you'll probably start off by coding just the two human players, and then you go on to moving to coding like Minimax, which is the computer player, and figuring out the logic of that. And that's kind of when the timeline and the referee come into play.
Okay, now we're going to talk about move validity and flipping. So like Sarah was talking about, you have to make a sandwich if you're putting your piece down with the other player's pieces in Othello. And then once you do that, all of the pieces of the other player's color in the middle of the sandwich flip to your color. Okay, so if there was no such thing as a valid move in the game, it wouldn't be very fun because you wouldn't be able to go. So we need to be able to check for a valid mood. And this involves sort of two steps. We want to make sure that a board square is empty. Otherwise, you obviously can't put your piece there because there's another piece there. But we also want to make sure that a sandwich can be made by placing a piece at that position in the board, which just means you place your color, and then there's just a sequence of the other player's color all in a row, and then your color again. Okay, so for checking for sandwiches, you can either use recursion or iteration, but we strongly recommend recursion. Yeah, you basically start with a square, you check to see if the next square is of the opposite color, and then that can begin a sandwich. And then if so, you check into the next square and the next square and the next square and the next square until you reach a piece that has your own color, in which case the move is valid because it creates a sandwich. But if you reach an empty square or the edge of the board, that's not creating a sandwich. That's just a bunch of the other person's pieces. So the move is invalid. Each square on the board has 8 adjacent squares all around it. And if a sandwich is found in any of those directions, then the move is valid. And then a piece can be placed at that position. So one question to ask yourself is how you can check 8 directions in a code minimizing way. And this might involve factoring out checking in one direction into a helper method, which we highly recommend. So here's some pseudocode for checking sandwiches recursively, which is what is recommended. So this has to happen for each of the 8 directions around the square. You can see on the lower right, there's a little diagram of putting a white piece down and then having some sandwiches in different directions. So some things to note are this check one direction method takes in a seen opponent variable, and that just represents if you have gone through in a direction and seen a piece of the opponent's color. So you basically check first, like we were talking about, to see if this is even a valid square to move at all. So to make sure it's empty or whatever, out of bounds, that kind of thing. And then you check if the next or if the board square has one of the opponent's pieces. And then if so, you continue in that direction, but you pass in true for seen opponent. And then if you have seen one of your own pieces and the next square is your own piece, then you return true. And that's how you can do a little recursive checking in one direction. You could also do this iteratively, but you'd have to loop through the 8 directions and then use while loops to keep track of whether a sandwich has been made. It does the same thing as recursion, so you can think about it if you want to on your own, but recursion might be a little cleaner. Okay, so the next step after putting down a piece, after you've checked and made sure that this is a valid move, we need to figure out how to flip the sandwich pieces. And so once you place a piece, you have to check in each directions to see which pieces have been sandwiched, because you can have sandwiches in multiple directions. And so for each direction where you find a sandwich, flip all of the pieces in the middle of the sandwich until you reach a piece of your own color. Again, we can either do this recursively or iteratively. And it's a really similar algorithm for checking if there is a sandwich. And then if you use recursion, you could even combine these methods into one. So checking if a move is valid or if there's a sandwich in one direction and then flipping. And you maybe use a conditional to check if we're in like flip mode or not. And then if you get to the edge of the board, something's gone wrong. You shouldn't ever reach an edge when you're flipping because remember, you have to reach your own piece at the end of a sandwich. And a sandwich could be created in more than one direction. So make sure you're flipping pieces in all directions that have a sandwich, not just one. And after your flipping works, then you'll almost be done with human player.
Okay, awesome. Now for the fun stuff. We're going to be talking about copy constructors. So, as a little background, copy constructors, you've seen this before in method overloading. And so in Java, we can use a design pattern called method overloading, where we create multiple methods of the same name, only if they take different arguments as argument lists. And so this allows us to write methods that have a similar end goal, but can achieve different things depending on the inputs. So as an example, let's say I want to create a sum method, and I want to be able to add in the cases where my inputs are 1, 2 ints, 2, 3 ints, and 3, 2 doubles. So here they are, and you can see in every single one, they all have the same name and declaration. So it's public int sum. It's going to return an int. But where they differ are both their parameters and what they actually return. So literally, this one has int A and int B as their parameters, and this one has int A, int B, and int C. And then this is awesome because now we can have 3 different types of sum methods that we can call at runtime. And so the compiler will call whichever method matches the arguments. So in your code, whichever arguments that you end up writing inside of your method call will automatically, Java will know to call which one it matches with. Okay, and you've also seen this before in Java FX. So in your in your like what's it called? Composite shape classes and stuff, you might have noticed that when you start typing in like rectangle, it'll like give you several options of different types of rectangles you can do. And so that's method overloading. If you gave it like, oh my God, keep clicking. Sorry, y'all. If you gave it one set of arguments versus the other, Java would automatically know which one to do. Okay, so now let's move that logic over to copy constructors. So constructors, as you know, are also methods, and they're obviously methods used in a different way. They're used to initialize something, but they are still methods, so method overloading applies to them. And we can use this to test out our moves in Minimax. So the benefits of using a copy constructor, it lets you replicate the current state of the game by producing a distinct instance that is logically identical to the visual game board. And as a note, this is in addition to your logical representation of the board we see visually. So in Minimax, we want to be able to see a couple moves ahead, but you don't want to affect your actual game board while you're checking several moves ahead, if that makes sense. So like, for example, if you're pretending to be the opponent in the next round, you don't want to actually put down that pretend opponent piece on the board. So copy constructors let you mimic your current state of board by copying your current board. And yes, so similar to method overloading, a copy constructor will create an overloaded constructor for a class. And that's right, your board class will have two constructors, and it will take in exactly one parameter. And this parameter is a reference to some instance of the same class. So here they wrote public car Toyota. So you're passing in an instance of your own class, which might look trippy, but we'll show you an example. So copy constructor then uses accessors to retrieve important information from the instance, and then it assigns the same exact values to itself. And as a note, you should never copy objects from one class to another, only primitive types like ints and booleans. And the reason for this is you don't want to accidentally edit your actual current state of your game. And so in Java, if you pass in a reference to something, then if you edit that reference, you're going to be editing the original variable. And in our copy constructor, we don't want to be editing the original, like the actual game. Okay, so here's a little code example. So in this code example, we have a class flower, and you can see here, this is the normal constructor, and we elided that, but below the normal constructor is the copy constructor. And in its argument, it takes in its own type. So it's taking in a flower flow. And then here you can see in the instance variables, we are setting it equal to the actual flowers instance variable. So we're just doing this dot height equals flow dot get height, this dot type equals flow dot get flower type. And this ensures that in both game states, we have the same info. And okay, so this example would make an identical copy flower of whatever flower is passed in. And note that for the array of petal objects, we do not direct copy them like this. So we're not doing petal array equals flow dot get petals. We're doing instead, wait, sorry. Okay. And then remember, since objects are passed by reference, the above line would make the copied array point to the same exact petal, which we want to avoid. So instead of doing that, we're creating new petals, so new petal objects, and then we're passing in the old petal's color. And so this creates a new object instead of using the reference to the old flower array. And so as a hint, a board is just a 2D array of objects. So all we need to do is iterate through each location in input array and make a copy of its contents for each corresponding location in a new array. So yeah, some things to think about. Who's next?
All right, so now let's talk through some of the kind of higher level design that we might want to see for Othello. So since it's such a large project and there's a lot of different kind of components going on, there's a whole lot of different designs that totally can work. But make sure that whatever you choose to implement, that it abides by the kind of the design practices and standards that we've talked about through this class. And all the things that Andy has talked about with OOP and high cohesion, loose coupling, all that kind of stuff. There are many designs that will function and will totally make Othello work, and you wouldn't be able to tell by just running the game that they're any different at all. But a lot of some designs are more efficient and easier to implement than others, and will make your experience in coding it a lot better, and will make our experience in helping you and grading it a lot better as well. So just think about your design before you go in and really just kind of like start trying to bang this project out. So right now we'll go over some classes that you should consider using. And no, again, this is just the design that we recommend. There's a lot of different ways to go about doing it. I don't think the Othello that I made followed this exact program design either. So feel free to depart from this if you feel strongly about it. But again, this is what we recommend. And any decisions you make that kind of you think might be a departure from this, or ones that you think are in line with this, you should always justify your design choices in your README so that when we're grading, can kind of read that and know what you were going for. So here's some potential classes. Excuse me. That you should think about when implementing Othello. So first off, a setup game class, which can handle like the game setup logic. There's an empty class provided in the stencil. In the past, the game has been the top level logic class, but you'll find a lot of logic going into the board class, just because like the board is pretty much the entire game here. There's not really logic outside of board, like putting pieces down and flipping pieces, which is expected for Othello. So it's helpful here to have like a setup game class that can just pretty much like set up a new board and kind of handles like the settings and stuff like that. Your referee class. So Sarah talked about this a little bit earlier, but it can be used to manage the players and turn taking. I think this one is definitely one you should have. And just again, kind of like the tic-tac-toe controller thing, just tells the players like when to take their turns. The Othello square class, this is also a really important one to have. We need to have wrappers for our rectangles, especially if you want to just have the one 2D array rather than the two separate 2D arrays. This project would be really hard to do without making a wrapper class for your rectangles. So you should definitely have Othello squares that can represent a space on the board, and can also, if you want to, hold pieces, either be empty or hold a black piece or a white piece. I think it's also helpful to have a piece class, which is a wrapper, pretty much could be a wrapper of like the circles that you put on the board. You can consider if you need two classes for black or white pieces, or you can just create one class that can represent them both. But it will be helpful just because pieces will have specific functionalities, and you won't need to do pretty much all you'll need to do with a piece is like set its location and change its color. So that limits a lot from just the basic JavaFX circle. So that could be something to think about. A move class. This one kind of took me a while to wrap my head around when I was doing the project. I didn't really understand what it was for, but it's very helpful when you're doing the AI part and coming up with the different moves that an AI can make. So basically what it is it represents like a move that one of the computer players can make. And it does that by tracking the row and column of the move, like where, like what the move actually is in terms of like what square will be clicked on. And also the score of that move. So like how good will that move be if you made it? And tracking all this information will allow your AIs to consider making a whole bunch of different moves and figure out what the best moves to make actually are. And then your board class obviously will handle all the board updating logic, the copy constructors that Gino was just talking about, and all that. So this looks kind of scary at first glance, just because there's a lot of rectangles and arrows. But like, think about it. We're giving you a class and interface diagram. Like, this is crazy. This is nuts. So feel free to go back to this as much as you can. I didn't even realize when I was doing Othello that we were given this, and I totally wish I knew because it would have been super helpful. So here, but again, remember, this is just one design. This isn't like, final clean cut. This is what you have to do. Just one possibility. A few things I want to know. I won't go through the whole thing just because, there's a lot of rectangles. But some important things to point out about this design are this interface here at the bottom of this player interface that both human player and computer player implement. This could be really helpful so that your referee doesn't necessarily need to know if it's dealing with two human players, a human player and a computer player, or two computer players. It can still function the same way. So that's kind of really important for implementing your referee. Also notice that your referee takes in a timeline. That's really important. The referee should be handling since it's handling the turn taking, it should have the timeline as well. And also notice that the referee and the players kind of have a sort of a two-way association here, where the human player and computer player know about the referee, and the referee knows about player instances. And think about why this might be necessary, especially in terms of the referee telling players to move, and then how the referee knows to switch the turn to the other players. I think the rest of these are fairly self-explanatory in terms of the design, but feel free to ask questions about this diagram in hours or on Ed or anything if you have any questions. I definitely use this as a reference as you're coming up with your own design for the program.
Okay, here's some questions to ask yourself while you're coding or when you're getting ready to code. So one really important thing is, what is the move class? Figuring out what that is, how you're gonna use it. Do we need a board class? Where should the 2D array or arrays go? Do we need a referee class? The answer to that one is yes. So we're gonna nudge you in that direction. Othello square can have methods like get row and get column, so that the board doesn't need to convert from like YX to row column. It can also have methods like add piece, color, and that takes in a color, flip piece, and stuff like that. And this would be a wrapper class for your JavaFX rectangle. Also sort of like a smart square class. That one's not really a question, but sort of a suggestion. Okay, next, where and when should players be able to click? Where should the click logic go? And then in terms of polymorphism, you'll probably have to use this with your human and computer players. So what would they have in common, and how could you play without caring which player was playing, human or computer? And then in terms of association, what should the association be between setup game and the controls class? What about between the referee and the players? So do the players need to know about each other? And then how can we utilize parameter passing and setter methods to set up a two-way association? We do want to minimize association as much as possible, but how do the different board implementations impact association?
Awesome. Okay. Well, after that help or after all this info, we hope you choose Othello. We know it's a big choice, but there's a great team of TAs just waiting to help you and are really excited to help you. But if you are starting and you know you want to do Othello, start now. There's really no reason to wait. Hours have already started for Othello. And it's a big project. It's one of those projects where you need one step to be good before you can move on to the next step. And we really want to make sure you get human versus human working early so you have enough time to debug and write the human player algorithm and debug it. Don't underestimate Minimax. It's challenging algorithm to grasp conceptually and takes time to debug, but we might have another help session after Thanksgiving just for Minimax. That is to be determined. But something we want to also add is that all the other steps are just as important. Like flipping pieces is arguably just as hard as Minimax. It takes a lot of thinking, and that can take time to debug. So again, making sure your human versus human is working, so then Minimax goes smoothly is really important. Hand simulating is really important. Print lines, all the debugging skills we've taught you will really come into play now, and seeing yeah, it'll just help you debug your code, especially if you have to go to debugging hours. It'll also help the TA kind of pinpoint where they need to help you. Again, did we mention start now on any project that you're doing, especially because break is so late this week and you'll only have, I think, around 8 days, and you can't use late days again. So start now. And again, good luck. Othello's tough, but in our opinion, is the most gratifying final project to do. And we all love it. Yeah.
You're making the right choice.
Yes. Rush Othello.
Yes.
Okay, I'm gonna stop presenting, but does anyone have any questions? Totally okay if not. Yes. Um,
Oh.
yes. Oh yeah, perfect.
Yes.
If anyone has any questions, feel free to ask them. If not, that's okay. You can post them on Ed. And just make sure to fill out the final project declaration form that's posted on Ed, pinned by tonight. If not, you're free to go. This recording will also be posted, and the slides will be posted on the website sometime today, I believe.
Do Othello.
Do Othello. Spread the word.
Yeah, cool people do Othello.
Okay.
That's
Sorry. Thank you.
That's like taking that.